bond that involves the sharing of electron pairs between atoms. They can only occur between nonmetals. An example of a covalent bond would be H2O, which comprises of the two nonmetals hydrogen and oxygen. Now, how to make a covalent bond? To make a covalent bond, try to combine the nonmetals so that they fulfill the octet rule. The octet rule is that every atom wants to have 8 valence electrons except hydrogen, which only wants 2 valence electrons. So what does molecular geometry mean? Molecular geometry is the three-dimensional structure or arrangement of atoms in a molecule. Understanding molecular geometry of a compound is important because it helps determine its polarity, reactivity, and states of matter. Different compounds have different molecular geometries in order to express the amount of lone pairs and regions of bonding electron density.
So now we're at one of the most important parts, drawing the covalent structure itself. So the first step of this is finding the number of valence electrons in the compound. So the goal is to add up the total number of valence electrons, which should always be an even number. If the compound has a negative charge, add electrons, but subtract for a positive charge. An example is carbon dioxide. Carbon has 4 valence electrons, oxygen has 6. So the total valence electrons would be 4 plus 12, which is 16. So the second step would be drawing a skeleton structure. So create a skeleton structure for the covalent structure by placing all the elements with the central atom in the middle of the structure. If a carbon atom is present, it will be the central atom. However, if there is no carbon, the atom that there is least of is a central atom. So for carbon dioxide, there is a carbon present, so therefore it is the central atom, and the structure will be drawn out soon. So carbon's in the middle, the 2 oxygens are drawn, and 2 lines are drawn to represent the bonds. Step 3 is drawing the bond lines. So draw a line to represent a bond and 2 valence electrons from the central atom to each of the surrounding elements, which has already been done in the previous step. If the compound is an ion, draw brackets around the structure and indicate the charge at the top right. Next, subtract the number of valence electrons drawn through the skeleton structure from the total number of valence electrons to find the remaining number of valence electrons. And in this case, the remaining valence electrons would be 16 minus 4, which is 12. The final step is lone pairs. Lone pairs are 2 dots that represent 2 electrons that go around the atom if it does not have 8 valence electrons through bonds already. If an atom does not have an octet of electrons, lone pairs can be shared to create either a double or triple bond to reach the octet. So now we can use carbon dioxide as an example again. So we're drawing the skeleton structure. And here dots are being used, 6 dots on each so that the oxygens can reach the octet. However, in this case, the carbon dioxide only has 4 valence electrons and not 8. So therefore, it does not have the octet of electrons that we are looking for. So in order to make this octet of electrons for the carbon, a lone pair from each oxygen can be shared to create a double bond. And therefore now, both the oxygens and the carbon have the octet of electrons. And keep in mind that every atom should have an octet of electrons in the structure, but hydrogen atoms should only have 2 electrons.
So, molecular geometry rules. Number 1 is linear, which is 180 degrees with 0 lone pairs, and has 2 bonding regions. Number 2 is trigonal planar, which is 120 degrees with 0 lone pairs and 3 bonding regions. Number 3 is bent with 120 degrees, 1 lone pair, 2 bonding regions. Number 4 is tetrahedral, which is 109.5 with 0 lone pairs and 4 bonding regions. 5 is pyramidal, which is 109.5 with 1 lone pair and 3 bonding regions. And number 6 is bent with 109.5 degrees, 2 lone pairs and 2 bonding regions. Examples. First example is CH2O. Total valence electrons in CH2O will be 12 because 4 plus 1 plus 1 plus 6. And then you'll have the carbon in the middle and the hydrogens on the sides.
And then the remaining valence electrons you'll have is 6 because you do 12 minus 6. This is your final example with the double bond on top and the oxygen having 2 valence electrons on each side. This is the molecular geometry of the trigonal planar. It's just flipped because the hydrogens are on each side and the bonds are a little bent. For example, this example is NH4+. Total valence electrons in NH4+ is 4 minus 1 plus 5, which is 8. The N in the middle, and there's 3 H's, 2 on the side and 1 in the front, and another on the back. This would be the remaining valence electrons of this and NH4 would be 8 minus 8 is equal to 0. The molecular geometry of NH4+ is tetrahedral. For example, you have the plus on the outside.
So the next example we have is SO2. The total valence electrons is 18 because all 3 of those elements each have 6 valence electrons. So for the skeleton structure, you would have an SO and another O, and with 2 bond lines. And the remaining valence electrons is 18 minus 6, which is 12. The molecular geometry in this case is bent and 120 degrees. And here we would also have a double bond because for the sulfur to have an octet of electrons.
This example is NH3. Total of valence electrons in NH3 would be 8 because 5 plus 3. To form the geometry structure, you would have the N in the middle and then the 3 H's on each side. The next structure I'll be talking about is H2O. The total valence electrons in H2O is 8 because there's 2 hydrogens and just 1 oxygen, so it'd be 6. The molecular geometry of this would be bent, so you'd have the 2 oxygens branching out from the oxygen with two valence electrons on top, making it 2, 4, 6.
You got me like crazy, but you calling.